Hello everyone, this is Dr. Maha Abdurrahman. I'll be working now one of the challenging questions in exam Cambridge 2020, the specimen paper, paper 4. I'll work on question 5. Question 5 is about penicillin as an antibiotic produced by the fungus Penicillin. And this figure shows you the fermenter that works to do the process of penicillin production. And so that's the fermenter, and this is the filter where they use to filter the unwanted fungi and then take the filtrate that contains penicillin for using as antibiotic. As you see, there's an water in, water out jacket surrounding the fermenter, and fungus and uterus are entering from here. Acid or alkali are entering from the other side. There's a stirring paddle that helps to stir the fungi and all the nutrients in the container around. And there's a temperature monitoring as well over here. And there's a pH monitor just to check the temperature and the pH are optimum for this fungi to work. That was a summary of the diagram. Now let's move to the 6 marks question. Explain why there is a water jacket around the fermenter and why acid and alkalis are added to the fermenter. Basically, they're talking about this water jacket over here that deposit a cool water in and then there's another outlet for the cool water out. And basically, I would say the reason for that to maintain constant temperature. Okay, I need to maintain constant temperature. Okay, which is the best temperature for fungus enzymes to work, okay, because basically overheating could cause the enzymes denaturation, and I don't want that to happen. Okay, so that's why the water jacket is there to cool down and also release excess heat in the fermenter. Okay, now the other part of the question, why alkalis and acids are added, basically it's the same idea. So also, as the water jacket was there to maintain a constant temperature, the acid or alkali are added to maintain optimum pH. So to maintain constant pH, this constant pH is the optimum, or it should be the optimum pH for, again, the fungus enzymes to work, for the fungus enzymes to work. Okay, so this will help to maximize the yield of this reaction, or maximize the rate of the reaction inside this container. Okay, so that was the 6 marks question and how to attain it. It's more or less a common sense added to some information that we have about the optimum temperature and optimum pH needed for enzymes to work. Now let's move to this figure, and it shows the mass of the fungus and the yield of the penicillin during fermentation process. That's the time, and that's the mass of the fungus in gram per decimeter cube on the axis, on this y1 axis, on this y2 axis, there's the yield of penicillin in arbitrary units. Now state the time interval over which the fungus grew at its maximum rate. So I need to look at the fungus growth curve, which is this one, okay? And I can see clearly that the maximum growth for fungus was at this point, which equivalent on the x-axis to 120 hours. Okay, but they're asking about the time interval where the maximum rate of the growth, not the maximum growth. This is really very tricky question, because if you want to look at the maximum time for growth of the fungus, it would be 120 hours, right? But they don't want that. They want the maximum rate of growth. The maximum rate, not the maximum growth. I want to stress on this point. Maximum growth would be at 20 gram, which is at 120 hour. But since they want the maximum rate of growth, that's to say the maximum amount of growth per time, which I can see clearly here on the curve at this point. This huge increase in the mass compared to time, which is from 40 till 50 hours, okay? So they want the time interval where the fungus grew at the maximum rate, which is this, okay? From 40 to 50 hours was the time interval where the fungus grew at the maximum rate. And this word rate made a very big change in the answer, as you saw. So that's a tricky question that I wanted to stress on. Now, this other one, as the fungus grow in the fermenter, the nuclei in the fungal hyphae divide. State the type of nuclear division that occurs during the growth of the fungi. And definitely, because the fungi is dividing asexually, I'm going to choose the mitosis as the type of growth. Moving to the other question, explain why growth of fungi slows down and stop. As I see here, there's a plateau over there. And this, of course, is explained because nutrients are used up. Okay. There's also an increase in waste products. So I would say also accumulation of waste products as the fungus number increases, okay? And as well, you have the accumulation of penicillin, right? We said, this fungus will make a lot of penicillin, okay? So I would say also accumulation of the penicillin would inhibit the growth. Okay, so as well as accumulation of penicillin would inhibit the fungus growth. Okay. So that's it for explain the growth of a fungus. Why does it slow down and stop? Okay. Now let's move to C. Now what C says is penicillin is not for the growth of this is not needed. The penicillin is not needed for the growth of this organism, the Penicillin chrysogenome. State the evidence from figure 5.2 that shows that penicillin is not needed for growth of this fungus. If I look at the figure over here, I'll see that even before penicillin production, which was at 20 hours, the fungus has still grown, right? So that's why I would claim the reason here is that fungus was growing when no penicillin was produced, okay, and that was during the first 20 hours, okay. So that's the one mark, and that's the second mark. Now the people in charge of penicillin production emptied the fermenter after 160 hours. Use the information in figure 5.2 to suggest why they did not allow fermentation to continue for longer than 160 hours. Let's check. Longer than 160 hours. Now look at the amount of the penicillin starting from 140 to 160. It kind of kind of levels off and starts to become constant. So there is no point of not collecting the penicillin at that time, because simply there is no increase in the production of the penicillin. And even if you check, the growth of the fungus is also leveling off. So I'm not even getting more fungus population. Okay, so there's no point of not collecting the penicillin at that time. So I would say, and that's a 1 mark question, because no further production of penicillin. That's why I have to collect it at 160. Downstream processing refers to all the processes that occurs to the contents of the fermenter after it's emptied. This involves making penicillin into a form that can be used as a medicine. Suggest why downstream processing is necessary. Now this process, which is the one that is shown here in the diagram, if you look here, this where you are filtering the residue out and then taking the filter that is containing penicillin and then start to treat it, okay? Where you're trying to purify the penicillin, remove the waste and the toxins, products resulting from the fungus, and then try to give it a good shape, okay, make it into pill or into syrup. So that's why this downstream processing is very, very important. So I would say because, or why is it necessarily? Because it involves purifying penicillin, removing the waste coming from fungus, okay. Not only removing the waste coming from, removing the fungus itself, okay. So separating fungus from penicillin, okay. And also they're asking, it can be made into medicine. So making or enhancing the taste and the color, etc. This is why this is very, very important step. Explain why antibiotics such as penicillin affect the bacteria but not the viruses. This question is very common. Now, viruses, they have no cell wall. They have no enzymes that the antibiotics can really stop. How antibiotics can suspend the growth of bacteria, that they stop the growth of the bacteria, they stop the enzymes working, they stop the growth of the cell wall, and in all cases viruses do not have cell wall and they do not have any enzymes. So I would say that antibiotic the way they kill the bacteria, they stop enzymes in bacteria from working, okay? And I would say that viruses have no enzymes. They actually also have no metabolism that can be interrupted by these antibiotic. Okay? That's one mark and that's the other mark. And this concludes my question that I was intending to solve today. I hope it was useful, and I will come up for more challenging questions soon. Thank you so much for watching.